Welcome to SAT School. This is our first video on radical and short. Now let's get started. So we start from rational number. A rational number is a number that can be expressed as a fraction. For example, here we have a number which is a fraction. So any number which can be expressed in this form, they are rational number. Again, a rational number can be expressed as a fraction. Here this a divided by b is a fraction. In a fraction, this a is called a numerator and this b is called denominator. Again, any number that can be expressed as a fraction is a rational number. So here we have an example of rational number which is a divided by b, and in that the first is the numerator or this number and the number below is the denominator. So numerator and denominator. And the next property is both numerator as well as denominator in the fraction are integers. So to be a rational number, that number can be expressed as a fraction, and in that fraction we have a numerator and denominator, and this numerator as well as denominator should be integer. They may be positive integer or negative integer, but both a and b needs to be integer. Now here the denominator, which is b in this case, this denominator in a rational number cannot be 0, meaning the value of b cannot be 0. If b is 0, then that is not a rational number. Again, now so far we have three properties. The rational number is a number. That number can be expressed as a fraction like this one, and in that fraction this number is numerator and this number is denominator, and both numerator and denominator should be integers. Integers may be positive integers or negative integers, and this denominator must not be equals to 0 in a rational number. So to be a rational number, this b must not be 0. Now here are some examples of rational number. All integers may be positive integers or negative integers, all finite decimals, and similarly repeating decimals. So these are some examples of rational numbers. Here we have examples like 1. So this 1 is positive integers, minus 5 is negative integers. So 0.2, this is finite decimal number because it ends at 2, and this 3/2, which is in fact 1.5, this 3/2 is also a rational number. As we define here, that number can be expressed as a fraction. So you can express all these number as a fraction. Like here, this is repeating decimal, which is 0.6666. If you divide 2 by 3, then you will get a number in this form. So this is also a rational number, meaning these are repeating decimal, and this is finite decimal, which has finite number after decimal. So that is called the finite decimal, and this is repeating decimal. So all these are examples of rational number. Again, you can express all these as a fraction. Like this one can be expressed as 2 by 3, and this one is actually you can express by fraction, and this as well and this as well. Now here irrational number. Irrational number are real numbers that cannot be written as simple fraction. Like rational number, they can be expressed as a fraction, but these are the real numbers which cannot be expressed as simple fractions. Now here are some examples of the irrational number. So pi, root under 2, root under 3, all these are example of the irrational number. And these irrational numbers cannot be expressed as simple fraction. And even these irrational number, they have not repeating decimal, meaning these decimals, the numbers after decimals are not repeating, as well as these are not finite decimals, meaning there are infinite numbers. If you find root under 2, the value looks something like this, meaning there is infinite numbers after decimal and they are not repeating as well. Similarly, root under 3 is also equals to 1.73, and these are non-repeating decimal and these are not finite decimal. So when we discussed in rational numbers can be expressed as fraction and irrational numbers cannot be expressed as fraction. Like these three are just some examples of irrational number. The value if you find, then it looks something like this. Again, these are not finite decimal as well as these are not repeating decimals. As we discussed earlier, rational numbers are either integers, maybe positive or negative integers. They are finite decimals and they are repeating decimals. So these numbers are rational number, whereas irrational number, they are not repeating or they are not finite decimals and they cannot be expressed as simple fraction. Now, what is sort? Sorts are irrational numbers which are roots of positive integers. Remember these two. They are irrational numbers and they are roots of positive integers. So to be a sort, the sort should be irrational numbers as well as that should be the roots of positive integers. So these two properties. Now here are some example. So we know this root under 2 is irrational number and root under 3 and as well as this. All these are irrational numbers. If you find the value, they will be non-repeating and they will be infinite. So here the next property is roots of positive integer. Now here this 2, 3 and 7. All these are integers which are positive. So these are positive integers. If you find the value of these all three, then you will get a number or decimal which is non-terminating as well as non-repeating. So they are irrational number. Now here are two numbers, root under 4 and root under 9. Now if you find the value of this root under 4 or root under 9, simply if you find the square root of these two numbers, then you will get 2 and 3 respectively. That's why these two numbers are not sorts. If you find square roots of these numbers, then that will result in whole number. Like from root under 4 you will get 2 and from root under 9 you will get 3. So these are two numbers that you get from these two. That's why they are not sorts. Again, to be a sorts, those numbers should be irrational number. But here this is not irrational number and this is not as well. Now the next example is root under pi. Now the question is this a sort or not? This is not a sort because pi is irrational. So to be a sort, the next property is roots of positive integers. So here this pi is not positive integer and this is irrational number. That's why this as a whole is not a surd. To be a surd, the number should be irrational, meaning this whole number is irrational, but these 2, 3 and 7, they should be positive integers. That's why this is not a surd. Next is order of surd. Now what is simply order of surd? It is the index of root. For example, here we have a surd. Let's suppose this is a surd. Now in this n represents the order of surd. Again, the order of surd indicates the index of root, and this n is the index of this surd, and that is called the order of surd. Now the next is this sign is called the radical sign. This root sign is called radical sign, and this a is called radicand. So remember, now this number represents the order of surd. This sign is called radical sign, and this number is called radicand. Now here is practice question 1. You are asked to find the order of this surd. Now we know the order of surd is this number, which is 5. So the order of surd is 5. Now here is practice question 2. You have to find the order of this surd. If this is a surd, then what is the order? I think you know that. I think you can find out this. So this much for today. I'll meet you in next video. If you have not subscribed our channel, please do subscribe and press the bell icon so that you can get a notification as soon as I upload my next video. So take care. See you.